Hello, legends. This is Mr. Maze coming to you through the digital space, the wonderful verse that we've built together. And we are now on the last day of video notes for Unit 8. Unit 8 being the big fish unit, the magic unit, the unit that really brings together all of inference in a meaningful, substantive way. Again, you should have reviewed Unit 6, reviewed Unit 7, gotten all the way up through 8.3, and now we are on 8.4. And what is this? Of course, this is significance tests. For two means. We never knew we'd get this far. Well, that's not true. I always believed. You pushed through, found that last little bit of motivation in your druthers, and we are pressing ever forward. If you will turn to your slideshow, move past the title slide on slide 12 and move to slide 13 with me. The first thing that I want to clarify is this idea of paired data and two-sample data. Now, the idea here is that with paired data, it is very much a one-to-one situation. What I mean by that is if there's a value in one data set, there's also a value that corresponds in the other data set, one-to-one. So like twins or before and after, how you did on a test before and how you did on a similar test after you, studied or did something of that sort. And there's an inherent dependence here. So the idea is that one thing is like a treatment for another thing. And so we put them through those rounds and we're able to compare one to the other. So the UCLA bookstore situation versus the Amazon bookstore situation is often a paired test. That's one we looked at in class, where the treatment is basically one of them's from one store, one's from the other, but it's the same book across the two. Versus, as you can see on slide 13, two-sample data, we have no natural pairing. What I mean by that is we may have the same number of each thing, but there's no way to pair them effectively. We might have 50 students that are male and 50 students that are not male, but there's no natural way to subtract one individual's value from another. They are not paired in that way, and for that reason, they are independent. And the thing I want you to remember here is that paired data is used as single sample, right? We do one sample where we find the sample difference for all of it. Versus two sample, of course, we use two samples. Slide 14, I give some examples of paired data. And on slides 15 and 16, I want you to take a second, see if you can remember from class, or if you forgot, this is a good chance to practice. Go ahead and pause the video on slide 15 and try to guess what 1, 2, 3, and 4 will be in terms of if they are paired or not. And you should have unpaused the video at this point. Hopefully it was a good time. We're in different spatial and temporal realms now, but that's okay. That's okay. You should have gotten that 1 is a two-sample test, 2 is a paired test, 3 is a paired test, and 4 is a two-sample test. And I have little reasons and explanations between each. The key here to remember on slide 17 is that for paired data, it is treated almost exclusively like single-sample data. So back to sort of Unit 7 stuff. It's just that for P, of course, we use the term mean difference, right? But we only do one parameter. For H, again, we use the term mean difference. In our A, our assumptions, we need 30 or more. Instead of central limit theorem for just one data set, it's 30 or more pairs of data, right? So there have to be 30 of one and 30 of the other. Because remember, in paired data, it's always the same number for each. And then for N, the name will be paired t-test for mean difference. Okay, and for the rest, for the T, the O, the M, and the S, just remember that all of that will go for single mean significance test. It'll be all the same as we saw for single mean significance tests. Now, what we're really here for, legends, as you see, moving ahead on slide 21, after having gone through an example of a paired test, what we're really here for, what we're really trying to make work, that's my little chutes and ladders move, is phantoms for two-sample t-test for difference of two means. So let's start with the P that we do for two-sample. mean significance tests. You are heroes. Oh, I'm so happy to be doing this with you. Our final set, and you better nail this unit test. I know you will. I know you will. Set our parameters. Mean 1 is the true mean. It's all the stuff we did with confidence intervals, ... And true mean number 2, the mu2, if you will. True mean, ... Right, so all of that should be context for what it is that we are measuring. True mean of one thing, true mean of the other thing. And those parameters are set. As you know, H, we're now on slide 22. The null will always be for these two sample tests, that mu1 is equal to mu2, or of course, alternately, you could say mu1 minus mu2 equals 0. Those are both acceptable. And you have three choices for alts. Either mu1 is greater than, mu1 is less than, or mu1 is not equal to mu2. Remember, of course, that the ordering on this matters, okay? So pick the one that makes sense for the problem. If you assign one value to mu1 and the other to mu2, know which one is which and know what the test is asking for. So align those effectively. We're now on to our A. You know these assumptions. I'll go through them really quickly. Option 1, is it random? That should be stated. Now, a lot of this is repeating, so you should know it like the back of your hand by now. Random stated, independent. Is it independent? We need 10 times our sample size to be less than the population of out. Or, for both of these, remember, the other option is that there is random assignment for an experiment. And if that happens, that's your other option, right? So that's your like get out of jail free card. Either random and 10%, or we have random assignment for an experiment. Then you must, of course, also do whether it is approximately normal. And if it is approximately normal, what do? We either do the central limit theorem, which amounts to n1 being greater than or equal to 30 and n2 being greater than or equal to 30. Remember, we normally pool when we do hypothesis tests, but we are only in this class pooling for hypothesis tests for proportions. There will be no pooling for hypothesis tests for means. And also there will be no pooling for hypothesis for confidence intervals at all, either proportions or means, it doesn't matter. Okay, the other option for approximately normal is, of course, if the sample data has no skew, no outliers. Cool. And we should have that down. Our assumptions have been met. Now we're on the N from phantoms. What do? We name it. It is a 2-sample t-test for mu1 minus mu2. Do not forget that, and do not forget how to present that. We're on slide 25 now. Looking at the equation we normally do for this, you should know that setup. It is the sample statistic, which is mu1 minus mu2, minus the parameter, 0, over the standard deviation of statistic, which is the the equation that we normally do for these types of setups. The situation where we have our standard deviation for the population over the square root of n. And of course, we functionally make use of our test statistic in that case, right? Now, are you ever going to do this by hand? No, you are not, because that would be horrific and it would break hearts in ways unimaginable. So what we do instead is we do our T and our O injunction together. And we go to stat. We go to test. And we go to 2samp t-test. Right? And once you've done that, you will input your values, x bar 1, x bar 2, standard deviation for 1, standard deviation for 2, and then our n values. Please note that because it's x bar 1 and x bar 2, you can do decimals. for both of these, right? But for proportions, you cannot, because x is not x bar in proportions. It is x1 and x2, which represent number of successes. And those have to be whole people, because as we talked about, my days in Bermuda led to situations where we can never have parts of a person. It's just never worked out well for us or the law. So you've done your T and your O. You know how to run this calculation, okay? And of course, we will then do our M and our S, which should be, again, like the back of your hand. We will take the p-value and we will compare it to the alpha. It is either less than or greater than or equal to. And then we will, as it says on slide 27, I'm not going to write it down, but you have it on slide 27, you'll either reject or fail to reject the null. And then you will either say there is convincing evidence for the alternate using context, or say there is not convincing evidence for the alternate using context. Do not forget your context. And then on slide 28, we simply go through type 1 and type 2 errors. One last time for the cheap seats. Remember, type 1 is alt people. What that means is we reject the null when we shouldn't. And type 2 is, of course, old people. We fail to reject null. Oh, my handwriting's getting horrific. This is what happens at the end of the school day. I left everything out on the table for you legends. When we should reject. Know that and remember for both of these, context. Do not forget your context for these problems. It shows that you know what's going on and what to do with it, okay? You should know this like the back of your hand, okay? You should know this like anything of import that you do. It is a beautiful thing. Be aware that 2SAMP t-test is option number 4, so don't let that get in the way. And the last thing last, remember, if you are using raw data, now this was in the 8.3 notes too, so I want to go over it one more time though. If you're using raw data, one more time for the cheap seats, go to stat, okay? Go to edit. And once you've done edit, input for L1 and L2. This I'll do as its own little corner. Put your inputs for L1 and L2. There are data spots for those values, and you'll input them, okay? Once you've done that, go to stat again, okay? And then you'll do exactly what you think you will do. It's everything I said here. You'll go to test. You'll pick number 4, which is 2SAMP. Remember, SAMP is always 4 means 2SAMP t-test. And then the one thing that will change is you'll pick data, not stats. And then everything will work out as you want it to. Be sure you know how to read these setups, how to do what it is you need to do. You are legends and you are brilliant, okay? And I don't want you mixing up or messing things up in this category, because it's super, super straightforward, especially since we know all of the intricacies of it, right? So know every single component, be methodological about this. And the last thing I want you to know in terms of raw data is to clear. What you do is the following. Oh, I should probably do colon. What you do is the following. You'll go to stat, right? You'll go to edit. So now you're under your raw data. Then go up to L1 or L2. And what I mean is go until it's highlighting over the L1 tag or the L2 tag. Then you'll click the following. Enter, clear, enter. And lo and behold, it will clear the entire row for that, so you can start fresh. Legends, we have done it. We've gotten through all of the 8-point video notes, finishing up with 8.4. You now how to do significance test for 2 means. Remember, you are built different. You are built for this. And with me together, we can do anything magnificent in the realm of statistics. Beyond that, I can't help you. But, you know, I mean, I can't help you with a car loan. But this is where we're built to roll. Do brilliantly on this test. When you do, I will bring Miles through to dance for you, and so you can hold him one more time. And then I'm sure many more times to come before the end of the year. I'm proud of you. Thank you for being my students. This is Mr. Mays signing off.